I mean. Okay, so I'm gonna make up. I'm sorry, I just came from class. I was behind. They they had a few questions. So at the page, this is week 7, so it must be 13th. So we did.
I think we have 24.6, right? We didn't.
No, we
cover.
didn't. It just we only used the x-intercepts on that section, and we did it. We're not doing. I am way behind. For the curve sketching, I have done enough. Unless you have a question.
Okay.
Okay, thank you. 24.6. They talk about x-intercepts and so on. So they want to refine the curve, you know. So more curve sketching, you know, they find x-intercepts, asymptotes, and so on. So I would just do that. I don't think, usually I do that when I have time. So I think I picked the x-intercept concept from that. I think that's good enough. From my syllabus, I am kind of very behind. When I have time, I'll get back to that if it's necessary. Okay. All right. So we'll so we did okay. So we did only the 5th. Any questions from the sections that we have covered? All right. Lecture 14. This is about applied. This is section. So I'm going to share my page anyway. So we have some procedures that we can follow to solve an applied maxima and minimum. These problems are mostly called optimization problems. Okay. Optimization problems or maximum and minimum problems. They are word problems. Whatever we apply on the curve will be applied on the problem. The same thing. The you know, the hump, like that is a critical number x, and then that is a local maximum. If that graph was showing as a profit equation, then that would be the maximum value. local maximum value, and so is with the minimum value, right? So there are applications we want to see a little bit before we move on. So I have 2 chapters to finish yet, chapter 20 and chapter 27. We are a little bit behind. We are halfway right now, beyond halfway. So I'm worried about these 2. These are more complicated chapters. I wanna move on with the graphs. We have got good grip or understanding of sketching a curve. We did just to review what we have done. We did the critical numbers, which I will ask on the test. Critical numbers, inflection numbers, or points, as a matter of fact, inflection points or numbers. And then we talk about concavity, which one is, where is it concave up, concave down, and we have increasing and decreasing. All right. And 24.6, they say x-intercepts. These are the most important to complete the graph. X-intercepts. Of course, they say asymptotes too, but they don't even define them based on the limit. The asymptotes are those, say, for example, y is equal to 1 over x equals 0 is an asymptote, or x minus 1, then x equal to 1 is an asymptote, where it fails, it has a vertical asymptote like that, and the graph would be like that. Okay, so the discontinuity, we did them in MTH 128, right? So their answer 24.6 is already included because I already considered x-intercept for some of the questions, So I will move on. I just want to ask you this on the test. That's it. On if you have any concerns in terms of the section, you can do them, and you can ask me questions if you want to understand more. Okay, was there a question?
Hey, I was wondering for the test, will it be similar to how the textbook was laid out, where we had like one equation for like 4 different questions, and we'd find like the inflection?
Which test?
I'm saying for the next test.
It is similar to what the test that we had.
It would be similar to how the homework was laid out, where we had one equation and we had to find one question. We'd had to find a critical number, and then the next question.
Yes. I'd say, for example, yes, I know what you're asking. So I will give you, say, y equal to x cubed minus 2x squared. This is easy anyway. Then I will ask, okay, find critical numbers. Test, find the maxima and minima, which are the critical numbers. You're going to test them. Or first I would start, find the increasing and decreasing, find the intervals of increasing, decreasing, intervals of increasing and decreasing. You have to make the sign chart. You have to have the critical numbers. And when the slope is positive, it goes increasing. Slope is negative, it goes decreasing. So from in here, it's increasing. In here, it's decreasing. You're going to answer that. Then I will say, I think the first must be find the critical numbers. The hump numbers, or the numbers of maximum. Find the critical numbers, and then intervals of increasing, and then you will have test the critical numbers for maxima and minima, right? And then I will ask inflection points of the same question. And I might ask, where is it concave up, concave down? And then sketch. That's it. Do you understand? Whoever asked me, I'm sorry, I didn't ask the name.
Yes, thank you.
Okay. So it will be one question with quite a few of them following. Okay. Is that the concept? Yeah. I hope I have answered the question, or what do you think? Something else? Okay. Thank you. Any other question? So you will have one graph question on the test, like I said, but it will have A, B, C, D, at least A, B, C, D. You will have to
Sir,
stay.
when is this test?
I don't know. It's week 9.
It's week 9. Okay.
Most likely week 9. It's on the syllabus.
Okay.
It's week 9 on usually on Thursdays for us because we have the extra time. We can use about 10 minutes or 20 minutes of an hour.
Okay, sounds good.
Okay. So I think where are we? We are in March break. You will have a March break before you test, I guess. I think so. We are in week 7 now, right? Yes, Dima. Yeah, we are in week 7. So next week is the last week before March break. So I think my test is week 9. So you will have 2 days after your March break. I don't know if that's good. Alrighty. So let's. You see my page? No. Now you see, I guess. Is that correct? Yes. Okay. So applied maximum and minimum problems. Okay. These are the procedure, I could say, is first, there is a word problem. They might ask you to really, oh, did I do, okay, recording, all right. So procedure, as a procedure we can take, suppose they give you a word problem asking you to find the maximum or the minimum value of a function. It could be profit, it could be voltage, it could be force, it could be anything. They just want to know the optimization problem of that question. A manager wants to know an optimum value within the feasible region, but then the calculus can help you, or derivatives can help you a little bit on doing that. So as a procedure, I would write like number 1 as determine the quantity f to be maximized or minimized. Sometimes you have to come up with your own formula. Determine the quantity f to be maximized maximum and minimum. And then the second one is take the derivative of f to find the critical numbers. Okay. The third one is, of course, set the derivatives equal to 0 of take the derivative of f to find the critical numbers. That is df by dx equal to 0. I don't need to say. And then those critical numbers are points of numbers will give us points of minimum, local minimum, maybe for technical purpose. And maximum. Okay, so answer accordingly as we are answer the question. Based on the required information. Info. So you might want to test them first. Test the critical numbers. just to make sure. Okay, these are the three procedures which I believe are important. So I will do some questions from textbook. Section 24.7. The questions are on page 758. So I will write a little bit quicker for the information because they are all word problems. All of them are word problems. So a very easy question, but important to understand the concept is number 4, a small oil refinery estimates that its daily profit P in dollars from refining X barrels of oil is P equal to 8x minus 0.02x squared. How many barrels should the company produce? Should be refined for maximum daily profit. And what is the maximum profit? So, you know, they don't want to, these guys, they don't want to guess. They want to analyze it so that they will have definite answer to the, so obviously this is a quadratic, it's a quadratic formula. They could have done it without calculus, but anyway, because a quadratic formula has one maximum, either maximum or minimum point, and that's the point that they want to find. But the profit and the number of barrels of oil is related by P equal to 8x minus 0.02x squared. So we need critical numbers. As we said, this is optimization problem. We want to optimize it, like we want to find maximum profit and what value of x is appropriate to have maximum profit. They could randomly say, okay, let's produce 1,000 barrels, but then the profit according to the formula might not be maximum. No, they might lose. So that is the essence, like why mostly managers or engineers are interested in this, because they want to optimize the solution rather than randomly selected solution. So dP by dx is 8 minus 0.04 x, and if we let that equal to 0, we will get the critical number. So this is 8 equal to 0.04 x, then x becomes 8 over 0.04, which is equal to 200. That's 200 barrels for x, right? So therefore, well, we can test even that, because they say that's a maximum. There is no guarantee if it's a maximum. We have to test it. I think second derivative test is better. Use to test the critical number. There are two ways. We want first derivative test or second derivative test. Second derivative test is better because this is the derivative. The second derivative of this is easy. So I don't know. It's your choice. dp squared by dx squared is negative 0.04. So for x, for the critical number x equal to 200, this is negative anyway. If it's negative, then the critical number is a point of maximum, right? Therefore, x equal to 200 is a point of maximum, or the x coordinate of the maximum point. So what is the maximum profit? So therefore, maximum profit when you plug the maximum or a critical number, which is of a maximum point, into the main function, which is a profit function. So profit equal to 8x minus 0.02, was it the book? 02x squared. So this is 8 times 200 minus 0.02 times 200 squared, and that is 800. So 800 barrels they have to produce. No, this is not barrels. This is money. This was the number of barrels. They have to produce 200 barrels to make 800 per day. Is the maximum profit. Does it make sense, everybody? What I did on that question? Hopefully, yes. If you have any question, you can always ask me. You can interrupt, or, you know.
How many barrels does make for $800 a day?
200. So they cannot randomly make. For the number of barrels, got to be 200 for a maximum profit of $800 per day. Make sense? It's a small company. Is there any follow-up question? Whoever asked me how many barrels, is that clear, or?
No, that's it.
Okay. All right, next question is number 8 is not like something that I like to do. I did it, but let's do number 10, for example. The altitude H in meters of a jet that goes into a dive. Then again turns. Upward is. These are easy in a way because they gave us the formula. Sometimes we have to make up the formula given by H equal to 16t cubed minus 240 t squared plus 10,000. That's the formula where t is the time in seconds. Well, after, like, they're very specific. After the start of the dive. So what is the altitude of the jet? When it turns up out of the dive, right? So here is the ground. It's like going down like that and going up. So this h is given by, so this is, I think, what they say they want, right? So the relationship between time and h, the height at any point for the plane or for the jet, is given by this as a solution. This is very important. The relationship between the two variables, h equals 16 t cubed 240 t squared plus 10,000. So we want to know the critical number. Okay, there could be well, there could be like that, you know. It's cubic function 1, 2, 3, you know. So there could be 2 points on the critical number, and then we have to determine which one is going to give us the value of h. So I think dh by dt is what we're going to find first, which is equal to 48 t squared minus 240 is 480 t. So when I do this equal to 0, they will give me critical numbers. So I'm going to factor 48t and t minus 10 equal to 0, isn't it? That's very, yeah, I expect you to go directly when you solve the derivative equal to 0. This is based on last semester's class, which is MTH 128. Mostly quadratics and cubes, they are based on factoring. So I expect factoring that you have done factoring with 128. Yeah. So this is common t. You can see there is also 48 common equal to 0, and then two numbers multiplied to give you 0. Each should be set to 0, because to explore all the possibilities of making the equation 0. So t equal to 0 over 48, t is equal to 10. So the optimum, the critical numbers are 0 and 10. Then again, I think you can find the chart method at 0 and at 10 and then check the slope, or you can find the second derivative, which is easier in this case. So d squared h by dt squared, the second derivative of that is what? Is actually 960 minus 480. Now, what does the second derivative test say? Second derivative test. Test states that if you plug your critical number into your second derivative and you get negative, it's maximum point. If it's positive, it's minimum point, right? So there was a comment. At t equal to 0 is maximum, yes. So if f double prime of a is less than 0, then a is maximum. If f double prime of a is greater than 0, then a is minimum. That's what we said. That's secondary test. So in here, you know that if you put 0 there, it's less than 0. The second derivative is less than 0, or negative, I would say, or negative. If it's negative, then the value you're plugging, t is equal to 0, is gives, I think I should use a different terminology, gives the maximum value. I mean the maximum value. So what is the second derivative of the second critical number? Second critical number is t equal to 10. When I plug 10 there, it's 960 minus 480. It's positive 480, which is positive. Which is minimum. Wasim, thank you, Wissam. So therefore, if it's positive, like by this guideline, this is minimum. Therefore, t equal to 10 gives the minimum value. So we are looking for a minimum h that the jet could dive out of the diving, you know. So therefore, that is the time that the minimum value is attained. What value of h is that? Okay, you get a plug. You already did it, Wissam. Okay, 2000. Okay, thank you so much, sir. Okay, so in h, we can he did it, but what we do normally is 16 times 10 cubed. I'm plugging it in here, you know, in here. That's where always the values come. The values are different from the t's or the x coordinates. The critical numbers are the one dimension. The values are the second dimension, you know. So if you were talking about graph, here is the time, here is the height. So these are critical numbers. Values come from the height. When they talk about the value of the maximum, they're talking about the second variable, the dependent variable. 16 times 10 cubed minus 240 times t squared is 10 squared the plus 10,000. And it's 2,000, did you say, Wissam? 2,000 in meters. So this is the altitude of the jet. The minimum altitude, actually, the minimum altitude of the jet before it came out of the dive. Okay. All right. So I take number 16. I want to do the sum of the length and the width of a rectangle table is 280. What is it? Let's do it together. The sum of the length L and width W of a rectangle rectangular table. Tabletop is to be 280 centimeters. Determine the length and width if the area of the table is to be maximum. If the area of the table to be maximum, I guess. So here we have a table top. So it is length, width. What did they say? The sum. What they gave us? So this is a problem, you know. Most of the time they give you the question and the relationship, and then in other cases you have to make up the equation itself. So what we know is that the sum of the lengths and the width is 280. Well, we know that's equation 1. Equation 2 is that the area, which is length times width, we want it maximized. We want it maximized. So I think it's always better to deal with with one variable, right? So I think I can express the area with one of the lengths or the width, it doesn't matter. So from equation 1, we know that the length is 280 minus width. 280 minus width. So the area would be simply the length is 280 minus width and times width. So what is this area depend on? On the width. This area is a function of the width, which is 280 width minus w squared. So he came up with the relationship between the width and the area is actually this relationship. He created that on your own. This is when they come difficult. So far, okay? So there are two equations. You solve one variable from the first equation and plug it in the second equation. And then the second equation is what they are asking you to maximize or minimize. That would be your equation. So therefore, now this is optimize this or maximize this, meaning that find the critical number, set it to 0 by find the derivative, set it to 0, get the critical number, test it, and then make a conclusion. That's what maximization is or optimization is. So what do we do? Well, a prime of w is simply 280 minus 2w, the derivative. And that is equal to 0 will help me to find the critical number. 280 equal to 2w. W is 280 over 2, which is 140. So what do we do? Well, I know we should test this. The derivative, okay, just for variety, I will use the first derivative test if you want, so we can review it. So this is 140. The derivative is 280 minus 2w. We want to test w less than 140. And then w greater than 140 because there are two intervals. And then take a number less than 140. What do you get here? If you take like 0, it's positive. You're going to take, okay, what is the derivative? 280 minus 2w. So at 140 is what we got. Yeah. So take a number less than 140, which is 0, which is positive. Or take a number greater than 140. Something messing up next. Yeah, but I'm not convinced. Are we not maximizing? Oh yeah. I'm just way ahead of myself. Okay, so this is negative. So therefore this goes up and goes down. So this is maximum. Okay, that's the first derivative test. So therefore w equal to 140 gives us the maximum value of what? Of the area. The area is a dependent variable. The w is the independent variable. So therefore we already determined. I know if the units are in centimeters. Yeah. So therefore, what is the maximum? What is the maximum area? We did it. Okay. 140, 19, 1600. Okay. 19,600. So the maximum area is 280 W minus W squared, which is 280 minus 140 minus 140 squared. And I'm sure we summarize it as 19,600. 19,600 centimeters squared would be the area of the table. The maximum area of the table. I think the dimensions is what they ask, but okay, if W gives the maximum value of the area, I could say the length is, or the length was what? 280 minus W, 280 minus W, which is 280 minus 140, which is equal to 140. So actually it's when it's a square. The maximum value is when it's a square. So the rectangle, note that the rectangle has, note that the rectangle has the maximum area when it is actually a square, as it is, like, because this is 140, this is 140. Okay, so when it's a square, the area would be maximum. Is that fair conclusion, you think? Yeah. So that is note, that's not what they were asking us. They were asking us what are the dimensions of the rectangle. When they are equal at 140, it gives us maximum area. Okay. So number 70 is more related to your field, which is civil. So I was thinking of, I know I was going to assign this as a homework. A rectangular hole is to be cut out of the vent. Rectangular hole is to be cut out of a vent. Okay, this is a rectangular hole, let's say. A perimeter of the hole is 48. So if this is x and y, then 2x plus 2y equal to, well, I'll give you the information. Perimeter equal to 48 centimeters. This is the hole, rectangular hole. For vent. Okay. The perimeter of that is it's rectangle. So perimeter is 48. What are they asking? So if the perimeter of the hole is 48 centimeters, the length of the diagonal is minimum. This is minimum. Let's call it D or L. Let me call it L. So we want, so what is the minimum L? What minimum value of L will make this happen? Okay. Okay. So I'm going to write that if the perimeter is that, if perimeter is that, and the length of the diagonal is minimum, what are the dimensions of the hole? Very similar to the number 16, but it is working interesting because it's a work related skill with math. That's why I picked it. But so then we know that as a solution, we know that the perimeter formula is the sum of all the sides of the figure, which is 2x plus 2y equal to whatever the perimeter is, 48. And then the diagonal. Now, they didn't talk about the area like number 16. They talk about diagonal. And we know by Pythagorean theorem, the diagonal square is x squared plus y squared. So now we have to minimize this. Minimize our function. The diagonal is L, not D. To minimize that, we've got to deal with one variable as much as we can. So therefore, we're going to find from this equation 1, you can find one of the variables. Like you can divide by 2 first, like x plus y equal to 24. And then y is 24 minus x. That is the value of y. I can plug it in here. And then I get L equal to L squared equal to x squared plus 24 minus x whole squared. If you want a polynomial for easier derivatives, it's better x squared plus 24 squared. You don't have to FOIL it. You could use chain rule. (576) minus 48x plus x squared. This becomes 2x squared minus 48x plus x 576 is L squared. So if you want to minimize, you have to find the critical number first, right? So well, you can use implicit 2L dl by dx equal to what? 4x minus 48, isn't it? So dl by dx is equal to 4x minus 48 over 2l over 2l. Are you with me so far? Did you follow me, or is there any problem with this question so far? You can take the square root and then find the derivative. It's the same. It will be 2L on the denominator when you take the square root. Okay, so I think, so what is L, by the way? L is what? So you can keep L to be, you know, the square root of all that. L is the square root of, what is it? 2x squared minus 48x plus 576. So you have 4x minus 48 over the square root of 2x squared minus 48x plus 576 times 2, is it? Anyway, this is easy because when you set it to 0, the denominator will, by cross multiplication, you have 4x minus 48 equal to 0. So 4x equal to 48, x equal to 48 over 4, which is equal to 12, is it? and what the units are. 17 centimeters. So X is, so I know this is always challenging for students. Is it clear? When you cross multiply and you have a big term in the denominator, if the right hand side is 0, then you're saved from that huge denominator, because 0 times that is what we're doing. So at X equal to 12 is what? We don't know. It's the only critical number. We can test it. Right? We can test it at 12. At 12, take a number less than. So take a number less than 12. It is negative here. Take a number 12. I'm looking at here, or even below here. Take a number less than 12. Say, put 11. 44 minus 48 is negative. Take a number above 12. Put 13. It is 52 minus 48 positive. So this is minimum point, as you can see. Why didn't I consider the denominator? Denominator is positive anyway. The sign is determined by the numerator only. This is what determines the sign, SIGN, of the whole quotient, because the denominator is always positive, because it's square root number multiplied by 2. It's always positive. So this actually, X equal to 12 centimeters is the dimension of the rectangle to give us minimum value, is the gives us, I think gives us the minimum value of the diagonal. So what is the other one? Then if X is minimum value, then what was Y? Y was somehow found from equation 1, 24 minus X. Yes, 12. Again, it is a square. The squares are very interesting. It's a 24 minus X at X equal to 12. This becomes 12 centimeter too. So therefore, again, then the diagonal is minimum, okay, when the rectangle is a square. In this case, so the diagonal is minimum of the rectangle is minimum when X equal to 12 centimeters and Y equal to 12 centimeters. So I can make a note here for all rectangles. The diagonal of a rectangle is minimum when it's a square. You can take examples and check. The diagonal of a rectangle is minimum, not maximum. The area was maximum when it was a square. Minimum when it is a square. Well, a square is a rectangle, you know. Okay. So I think with this we can take a break. Then I will see you in about 10 minutes. These are good examples of optimization problems, especially I thought they will be much related to your some physics questions we did, some business question about profit, and about mechanics of jet, and then we did a couple questions of geometry. Okay, so I will be on break. We will be on break, and then I will see you at 8 after 10. No, 11 or 8. Okay, is that okay? before we break, we have any questions to talk? Any issues, please? So I'll see you later then. Wissam, I got your email about the thing that I told you, and then we'll communicate from there. Okay? Anybody? Any questions at all? Then if none, I'll go on my break.